Hello everyone. We're going to be starting a new topic, which is volumes of revolution. And that topic, it's part of integration. It's an extension of the integration that you've done in normal maths. So let's get started. Let's quickly recap over what I hope you already know from normal maths. So if we've got this function here, y is a function of x, y equals f of x, and I asked you to find the area of this yellow section here between the limits a and b, hopefully you would know that the yellow area is the integral of y between a and b. Okay, hopefully that seems familiar. Now, what we're going to be thinking about in further maths is an extension of that. So rather than it just being an area bound by the curve and the axis, it's going to be the volume of a solid, and it's the solid that's created, you have to excuse my terrible drawing, when a curve is rotated around the x-axis. So today we'll only be dealing with it spinning around the x-axis, but later on in the course we'll deal with it spinning around the y-axis and a few other slightly different problems. So it's, if we were to rotate this curve around this axis, it would make a solid, which is essentially loads of infinitely thin circles put together. Okay. So when we think about working out the volume of this solid, we can use the formula for the area of a circle. So it's pi times the radius squared, and the radius of each circle, so this bit here, would have the radius y, and this bit here would have the radius y, and so on. So it's pi times the integral of y squared between the limits a and b. So let's have a go at a fairly straightforward example of that. So the example that we're going to have a look at, I've put the formula up there just to remind us, is if we wanted to find the volume of the solid created when y equals x squared plus 2 is rotated 2 pi radians, so a full rotation about the x-axis between x equals 1 and x equals 4. Now, I've done a little sketch here. You don't have to do that, but it's always nice just to visualise what we're working out. So we're working out the volume of this sort of trumpet bell type shape here. Okay, so first thing we're going to do is we're going to we'll write out what we're going to do. So we're going to integrate y equals x squared plus 2 all squared between 1 and 4 and multiply it by pi. So if we work out what x squared plus 2 all squared is, it's x to the power of 4 plus 4x squared plus 4. And if I integrate that, so you can pause the video here and have a little go if you want. And then I'll uncover my answer. So my solution, when I integrated it, I got x to the power of 5 over 5 plus 4x cubed over 3 plus 4x. And then substitute in my limits 4 and 1, multiply all by pi, and I got 1,503 over 5 pi units cubed. Great, so let's start by just having a go at some simple questions. So if you go to your Core Pure textbook, then doing questions 4, 6 and 8 on pages 74 and 75 would be a good start. And then next lesson, we'll have a think about rotating things around the y-axis. Small extensions of this that could come up are you might have to figure out what the limits are yourself. by figuring out where the curve crosses the x-axis. And you might also have to think about if it's not a full rotation around the x-axis, maybe it's just rotating pi radians about it or something like that. Okay, see you next lesson.